Hello class, today we're going to look at section 11.5, solving rational equations. Now, in this section we actually look at two different ways to solve these rational equations, but we're just going to focus on the one for now. So we do have two learning targets here. Again, we're just going to focus on the one. We're going to focus on solving rational equations by using this common denominator method. We can also solve rational equations by graphing, which is a great way to check your answer, but for now we're just going to focus on that common denominator method. Let's go ahead and get to work. So, let's look at our first example. X minus 1 over x plus 7 over 3x equals 9 over 4x. And we are going to solve this using the common denominator method. Now, here's what we do. For the common denominator method, we want to end up with all the same denominators. So we look at these three denominators. We have x, 3x, and 4x, and we think to ourselves, what would be the least common denominator? Okay? We want the smallest denominator that we can that still makes them all the same. So since we have an x, a 3x, and a 4x, we know our denominator will have an x in it. Then we need to look at the least common multiple between our coefficients, 1, 3, and 4. The least common multiple would be 12. So what we're going to do is we are going to multiply all these denominators by something so that they all end up being the same denominator of 12x. So to get x to 12x, I need to multiply it by 12. So we're going to multiply by 12 on the top and bottom, because this blue number is really technically 1, right? 12 divided by 12 is 1. So if we multiply this term by a creative form of 1, we're not changing anything. Just changing how it looks, really. 7 over 3x, to get 3x to 12, I need to multiply by 4. So we're going to multiply by 4 on the top and bottom. And then to get our 4x over here to 12, we need to multiply by 3 on the top and bottom. So again, what you should notice about all these blue numbers is that they're all 1. So really I'm just multiplying each term by a really creative form of 1, just to make it look how I want. So let's see what that gives us. That gives us 12 times x minus 1 over 12x plus 28 over 12x is equal to 27 over 12x. So now we have all common denominators. And then this is the really cool part. Once we have all common denominators, we can now just rewrite this entire equation without the denominators. So I'm just going to rewrite the entire equation, again without those denominators. So 12 times x minus 1 plus 28 equals 27. And now we just solve it like we would any other equation. I'm going to start by distributing the 12 here. So 12x minus 12 plus 28 equals 27. Negative 12 plus 28 would be 16. So 12x plus 16 equals 27. Subtract 16 from both sides, leaving us with 12x is equal to 11. Divide both sides by 12. Our final answer is x is equal to 11 over 12. So again, here's what I did. We got all the same denominators, and once we have all the same denominators, we can rewrite the equation just using the numerators. Okay? So once we have all the same denominators, just write our equation without the denominators, and then just solve your equation. Let's look at another example. Maybe a little tougher one. Example 2. 6 over x minus 1 plus 2 is equal to 12 over x squared minus 1. Now, I am going to write, just to help out a little bit, 2 instead of 2. I'm going to write that as 2 over 1. It's not necessary, but just to kind of give us an idea of what's going on. Now, you may be thinking to yourself, okay, Obviously, to get my 1 to look like our least common denominator, what would our least common denominator be? I could multiply our 1 by x squared minus 1 to give me x squared minus 1 in that denominator. But what do I multiply x minus 1 by to get to x squared minus 1? Well, here's a little tip for you. Anytime we have something that can be factored, factor it, okay? Because after you factor it, it's a lot easier to see what each individual factor is and then what we need to multiply by to match it. So here's what we're going to do. We're going to rewrite this. 6 over x minus 1 plus 2 over, and I'm just going to write that 1 again, not necessary, but just to help us see. And then this term. What you should notice, x squared minus 1, I have a perfect square minus a perfect square. Okay? It's a perfect square minus a perfect square, meaning this is a special pattern. It's difference of squares. To factor difference of squares, we take the square root of the first term, put it here and here. We take the square root of the second term, we put it here and here. We make one plus, and we make one minus. So now when we look at this, and we think, all right, we want to get common denominators, I see in my first term I already have the x minus 1. So all I need to do to get that as a common denominator, like this one, is I'm going to multiply by x plus 1 on the top and bottom. And again, that blue number there is really just 1. It's a really clever form of 1. It's a fancy form of 1, but it is still 1. All right? For my second term, we're going to multiply the top and bottom by x minus 1 and x plus 1. Okay? And then the term on the right side already has x plus 1 and x minus 1, so we don't need to change a thing. So let's go ahead and write this again just to be a little bit more neat. So here's what we have now. We have 6 times x plus 1 over x plus 1 times x minus 1 plus 2 times x minus 1 times, actually let's write it like this, x plus 1 times x minus 1, just changing the order a little bit just for sake of neatness, over x plus 1 times x minus 1, and that's equal to 12 over x plus 1 times x minus 1. So again, what we're doing here is we're using that common denominator method. What you can see now is now that I've multiplied by these special blue numbers, all right, now I have all the same denominators. Once we have it at a point where we have all the same denominators, we can then rewrite the equation just using the numerators. So 6 times x plus 1 plus 2 times x plus 1 times x minus 1 is equal to 12. Alright, and now we just need to solve. Let's go ahead and solve then. I am going to start by distributing my 6, leaving me with 6x plus 6. Here, we're going to multiply our x plus 1 times x minus 1. That gives me x squared minus 1. And again, we can tell that because we factored it before. But if you FOIL this out, you'll end up with x squared minus 1. And that's equal to 12. Let's go ahead and bring that up here for more space. So I'm just going to rewrite it. 6x plus 6 plus 2 times x squared minus 1 is equal to 12. Let's distribute the 2. So now we have 6x plus 6 plus 2x squared minus 2 is equal to 12. Let's combine like terms. And I'm going to write this in standard form as well. So how about 2x squared plus 6x plus 4 is equal to 12. And since we're trying to solve a quadratic equation, we know we want it equal to 0. So I'm going to move the 12 over. 2x squared plus 6x minus 8 equals 0. All right. Now we're actually to the point where we can solve for x. I'm going to, let's see if we can solve by factoring. First thing I'm going to do is factor out the greatest common factor, which would be a 2, leaving me with x squared plus 3x minus 4 equals 0. And then we gotta look, all right, can we factor this? So we need factors of negative 4 that add to 3. How about x plus 4, x minus 1? And now we just need to set each factor equal to 0 and solve. Start with the 2. 2 equals 0, there's no variable to solve for, there's nothing we can solve. We're just gonna ignore that. X plus 4 equals 0. Let's go ahead and solve that. Subtract 4 from both sides. X is equal to negative 4. And then my last one, x minus 1 equals 0. To solve, just add 1 to both sides. X is equal to 1. So after all of that work, our answers are x is equal to negative 4 and x is equal to 1. So, as you can see, these are a lot of work, or they can be a lot of work. Make sure you're showing all your work, make sure you're keeping it neat. I want to be able to award partial credit for these, so make that easy for me. But the key is, get your common denominators, and after you get the common denominators, rewrite the equation using just the numerators. Then past that, you're going to have to solve. If it ends up being a quadratic function like this, solve either by factoring. If you can't factor, maybe solve by completing the square. Solve using the quadratic formula, okay? We have a lot of strategies on how to solve equations. This is the new part of getting the common denominators. After that, we need to tap into our old knowledge of how to solve these equations. All right, these take practice. As you can see, they're long. If you have questions, let me know.